The development of artificial intelligence, AI agents, represents one of the most intriguing and transformative endeavors in technology today. These intelligent systems, designed to perform specific tasks or act autonomously within defined environments, embody the convergence of computational power, algorithmic sophistication, and human creativity. Their evolution reflects humanity's ongoing pursuit to create machines that can mimic, augment, and occasionally surpass human capabilities in problem-solving, decision-making, and interaction. At its core, the development of AI agents involves the meticulous crafting of algorithms that enable machines to perceive, reason, and learn from their surroundings. Whether it's a chatbot assisting with customer service or a robotic agent navigating hazardous terrains, the underlying architecture of these systems is driven by a blend of data analysis, pattern recognition, and feedback loops. These agents are not merely static tools. They are dynamic entities capable of adapting their behavior based on new information and evolving circumstances. This adaptability is one of the hallmarks of intelligent systems, setting them apart from conventional software and automation. One of the most compelling aspects of AI agent development is its versatility across domains. In healthcare, AI agents are revolutionizing diagnostics and treatment planning, analyzing patient data to offer precise recommendations and flagging early signs of illness that may otherwise go unnoticed. In finance, trading algorithms act as AI agents, monitoring markets, predicting trends, and executing decisions with unparalleled speed and accuracy. From autonomous vehicles navigating city streets to virtual assistants managing schedules and tasks, the potential applications of AI agents are as diverse as the challenges they aim to solve. Yet this versatility comes with unique demands. For an AI agent to operate effectively, it requires access to vast data sets and computational resources. These inputs serve as the foundation upon which the agent learns and improves its performance. Machine learning, particularly deep learning, plays a pivotal role in this process, enabling agents to identify patterns and make predictions based on historical data. Reinforcement learning further enhances their capabilities, allowing agents to optimize their actions through trial and error within simulated or real environments. These techniques, while powerful, necessitate careful oversight to ensure the quality and representativeness of training data, safeguarding against bias and inaccuracies. The development of AI agents also intersects with advancements in natural language processing, NLP, and computer vision. NLP empowers agents to understand and generate human language, enabling seamless communication between machines and users. Whether it's translating texts, answering queries, or summarizing content, the ability of agents to process language bridges the gap between technological complexity and user accessibility. Similarly, computer vision equips agents with the ability to interpret visual data, unlocking applications in areas such as surveillance, medical imaging, and autonomous navigation. Together, these capabilities expand the horizons of what AI agents can achieve. However, the journey to creating intelligent agents is not without ethical considerations and challenges. Issues of transparency and accountability arise as these systems become more autonomous. Ensuring that AI agents operate within defined ethical boundaries, make decisions that align with societal values, and remain explainable in their actions is essential to building trust and acceptance. The phenomenon of black box AI, where decisions are made without clear explanation, underscores the importance of developing agents that are not only powerful, but also interpretable. The integration of AI agents into the workforce has sparked debates about their impact on human employment. While these systems enhance productivity and streamline processes, they also disrupt traditional roles, necessitating a re-evaluation of workforce strategies and skill development. Preparing individuals for careers that complement AI agents, rather than compete with them, requires investments in education and training programs focused on creativity, critical thinking, and technical acumen. Collaboration and interdisciplinary innovation are key drivers in advancing AI agent development. Researchers, engineers, and ethicists must work together to address technical, social, and moral dimensions of these systems. Governments and organizations play a critical role in establishing frameworks for regulation and accountability, ensuring that AI agents serve the common good rather than narrow interests. By fostering an environment of cooperation and shared responsibility, the path to intelligent systems becomes one of empowerment and inclusivity. In envisioning the future of AI agents, the possibilities are as vast as they are transformative. The prospect of intelligent systems that seamlessly integrate into daily life, anticipate needs, and contribute to global challenges is both inspiring and cautionary. From agents that collaborate with humans in creative endeavors to those that tackle complex scientific problems, the potential to redefine how we live and work is immense. However, the realization of this potential must be guided by values of fairness, sustainability, and respect for human agency. Ultimately, the development of AI agents is a testament to humanity's ingenuity and ambition. It reflects our capacity to create systems that not only enhance our capabilities, but also challenge us to think critically about technology's role in society. As we navigate the intricate landscape of intelligent systems, let us approach their development with curiosity and humility, ensuring that they amplify the best of human potential. In doing so, we not only unlock the promise of AI agents, but also celebrate the boundless possibilities of collaboration between humans and machines.